Hello, everyone. I'm Leah Toms from the marketing team, and I'd like to welcome you to our introduction to private CAs. I have Jason Sirocco, SVP of Product, and Tim Callan, Chief Compliance Officer, here for you today. They're here to talk about what a private certificate authority is, different private CA use cases, how to choose the right PKI deployment, and then also best practices and considerations around private PKI. As always, we're recording this presentation and we'll share it with you after the webinar. If you've got any questions, we'd love to hear them. Please use the chat function and we'll answer as many as we can at the end. And with that, I'll hand you over to Jason and Tim.
Thank you, Leah. And I will also say that we have a new cover page. This is our new cover page. Yay. Very exciting. Hi, Jason. Good to talk to you today.
Hello, Tim. Glad to be here.
So I got to figure out how to click. There we go. So private CAs, walk us through the basic landscape here.
Yes, and in fact, I think a lot of the audience should be thinking, why private certificate authority? What's the difference between that and publicly trusted certificates? And what is the application? Isn't this just good old-fashioned PKI? And I'd like to address this on this slide to really make it clear. Let's do the first one, Tim. Publicly trusted versus privately trusted certificates. But publicly trusted certificates, as you guys hopefully know, are the certificates that you guys acquire and procure in order to be able to put into your web servers and load balancers to be able to encrypt traffic between web servers, load balancers, and web browsers. And that has been around a long time, Tim, and I know it's very close to your heart because that's a very important PKI use case. And what I would say is the difference now with private is, you might have heard about the term self-signed certificates. And, really,
or internal.
Yeah, they're meant for internal purposes. And what are those internal purposes? And I think that we're trying to, on the right-hand side, express all the different places where TLS certificates in a private walled garden sense have been employed. There have been human-based TLS certificates for a long time, and typically those are for the purposes of authentication or signing, right? So in other words, the SSL use case, the publicly trusted certificate use case, is typically thought of as an encryption use case. But in this case, most of these are somewhere between authentication and signing, and usually heavy on the authentication side. So the human use cases that you see here are handing out authentication certificates to be used to be able to log into systems.
Right. Device
and workload certificates, though, are really a big growth area that we are seeing. And it really, this gets to the heart of why I think we're doing this webinar, Tim, is it's the growth in this area. A lot of you may already be taking advantage of certificates that have been provisioned into mobile devices or desktop devices for the purposes of authentication again. And Tim, you and I have podcasted and done webinars on IoT, and certificates are also being used heavily within that realm for, again, the purposes of authentication. But now there's an entirely new wing of private trust use cases for certificates, and that includes things that you guys have been doing in the IT world for a while. But now it's about using those provisioning technologies, that getting certificates to humans, getting those certificates into devices. There's a whole host of technologies that have gotten certificates into those use cases that the industry is developing to be able to get certificates from whatever CA you need, whatever private certificate authority you're using, and then putting those certificates into those new modern use cases, such as workload identities, which is what they're called. So I hope that's a very quick rundown and differentiation between public and private, and the fact that we are really talking about, when we're talking about PKI in a modern sense or private certificate authorities, we are directly addressing specific use cases in the modern enterprise.
Now, Jason, correct me if I'm wrong, but when I see this green circle and it's humans, obviously I don't have a certificate tattooed on my forehead. Like, this still is sitting on, for want of a better word, I'll say some piece of hardware. It could be a laptop, it could be a mobile device, it could be a badge, it could be a dongle that's assigned to me, but it's something, right? There's still a thing, and those things are also captured to some degree in the physical stuff we see over in the left, or in the, what I want to say, non-human machine stuff that we see over on the left as well. Is that right?
You've got that absolutely right,
Right.
Tim. These certificates all are going to exist in some sort of digital environment. These are digital files we're talking about ultimately. And so therefore, when you see the word humans, absolutely, the private key and public key of that underlie all of this are not tattooed on your forehead at all. In fact, what's exactly a good thing, but what is happening is there is some digital system, some central authority where the registration of a human being to a key pair and ultimately the certificate is what is going on here. So just like Tim, in the publicly trusted world, you register a domain against a certificate, right? That's essentially what you're doing. With these different things, the reason why we have the labels, humans, devices, workloads, is because that is what is being registered rather than a domain. So I think that analogy holds.
Okay, cool. All right. So did we cover this? Like, I think we covered this, right?
I think, Tim, really, this is what I think we've covered definitely the public versus private. The key role is about authentication, signing, and encryption. And I got to tell you, Tim, maybe the last point to be made here is that private CAs really are more ubiquitous than you think. You might be thinking about a Microsoft CA. You might be thinking about a new private CA you've set up in the cloud for some authentication purpose. But I bet you there's other departments in your company, DevOps organizations that have a private certificate authority underneath their Kubernetes cluster. It's the foundation of everything.
Any cloud of containers has to have a CA or it simply doesn't work, right?
Exactly, Tim. And that's why we're labeling on the previous slide, you saw workload identities, containers. It's a perfect example of where you might have been working in the publicly trusted certificate space for years and never realized that there's other certificates all over your enterprise.
Right.
Just because those kinds of work tasks have been siloed, but private certificate authorities are everywhere.
And of course, the risk, and I don't know if I'm getting ahead of the slides here, so forgive me if I am, but the risk of having CAs operating that don't really have any kind of, what do I want to say, oversight from the appropriate department inside is that they might be weak, they might be non-compliant, they might not get updated, you might have outages caused by lack of certificate maintenance or certificate renewal. These are all things that really occur in the real world.
Tim, if I were to ask you a question right now, let's say you were a CIO running a big shop, and I asked you, Tim, can you guarantee me you're not running SHA-1 based certificates anywhere?
Right.
Question number one. Question number two, are you ready? Do you have an inventory of all of your cryptographic assets across your organization so that when the quantum apocalypse happens, you're ready to go? It's questions like this that we're trying to solve here.
Right. Okay. Yeah. So this sort of goes into some of the main use cases, I think.
Yeah, we just wanted to have one more slide to drive it home, just to make sure people realize device authentication, things like VPN authentication. These are things that I don't know an enterprise that doesn't have things like this.
Yeah.
And so therefore, it's just completely ubiquitous. Private CAs are already in every enterprise, and sometimes they're not being governed. Sometimes they're not being fully managed. The governance and risk programs are not looking at these things. I guarantee there are Kubernetes clusters running underneath people's desks right now with very important tasks that have a private CA that was literally instantiated by somebody who has never ever worked with PKI before and probably did not choose the correct defaults. That's a scary thought.
Yeah, and then and then one of the things you say a lot, Jason, and this is what this is, PKI is very different, right? This is your phrase, not your grandfather's PKI. You've said this on the Root Causes webinar many times. PKI is very different than what maybe we all remember when we went to school or we started in our careers, if you're kind of a gray hair like you and I are. Explain that.
Tim, I made sure that this slide was here just to really make the point. There are some of us who have been in this industry for a long time. And, you know, I'm saying, and I'm talking about even just more than 5 years. I would say you'd be a senior with respect to PKI, because the private certificate authorities that were set up back in those days, they were big, risky, expensive endeavors. Setting up a private CA could literally take months, and I don't even want to talk about the amounts of money, but we're talking about easily 6 figures into 7-figure implementations of PKI back in the day. And for those of you who are thinking that's what I'm referring to here, well, those kinds of things still exist. Big government, big military, big finance. What I'm talking about is device authentication, human authentication, workload identities authentication. Look, folks, today's private CAs are lightweight and so much faster to stand up, so much more highly productized than they ever were. And really, one of the biggest tasks to standing up a private CA today is not about, you know, the 2-week key signing ceremony and all these things we used to have to do. Tim, what it comes down to is making sure that your certificate profile is set correctly with your security provider, and making sure that exactly the things you talked about, making sure that you're not using SHA-1, making sure that you are using the right key length. Get those things right, and the rest of standing up.
And being able to prove it, right? Prove it not only to yourself, but prove it to your management chain, your board of directors, your customers, your regulatory agency, the people with whom you have SLAs, right?
Exactly, Tim. And if I were to add anything here, it's at the bottom, which is the sheer amount of provisioning technologies that we have now that are either open source or much easier to use than before. The ability to change things, have agility, the ability to audit things, and then the operating costs, the stand-up costs, the operating costs. My goodness, that to me is truly not your grandfather's PKI. Things have changed radically there because the business model around PKI has changed. And then what I would say is, I would say that cloud native PKI, which exists today, the way that it is architected, is so much more robust than the way things used to be, and ironically, a lot cheaper to implement.
Yeah, and so I just moved. We talk about this. Cloud, right? Obviously, the scalability, obviously the ability to do things like build-in CLM, and you know, we've talked a lot about the podcast. We had an episode not that long ago. We talked about the premise of on-premise, which is that it's fundamentally just more secure to use a modern SaaS cloud approach than have to try to do these things on your own floor with your own servers in your own physical environment.
Tim, you and I have podcasted on the sheer difficulty of configuring Microsoft Active Directory certificate services, and a white hat community having completely broken it down, and then building it back up again, providing PowerShell tools as an example to help prove to you how difficult these aging on-premise systems are. And so maybe the final point on this one, Tim, is that the amount of staff and the cost of the staff that's necessary. In fact, I bet you a lot of the people who originally implemented these systems are either wanting to get into a different stage of their career, and that stage might even be retirement. And so replacing these people, I don't think you're going to be able to. And so therefore, moving to a new architecture of PKI is the way to go. It's so much more highly productized. You don't need you don't need to have 2 PhDs on staff to be able to run the PKI. And then, of course, better security, better scalability, and operational efficiency is just not even to be questioned once you that's why we have such a gigantic cloud movement in IT in general.
Yeah. All right. So I think here you're sort of again touching on how for each of these like fundamental use cases, what's the difference between an old on-prem and a new modern cloud approach to these use cases? Want to walk through these one at
For
a
sure,
time?
Tim.
Device authentication?
Yeah, let's do it. I think for devices, we're kind of mixing ideas here of IoT and also mobile devices and laptops. Let's just talk about how you used to get the certificate into the device. I hate to say it, Tim, but it used to be that you had to sometimes ask people to manually implement a certificate. And I'll tell you what, that's dangerous, because self-signed certificates, once you've trained people to accept a self-signed certificate onto a mobile device, as an example, who knows where that came from? And so there are new best practices in automating how certificates get to the device, and then the scalability of rolling out. Tim, we saw in COVID enterprises struggling to get people to be able to work remotely en masse quickly. And I think that yesterday's PKI could never have handled it. And yet today, think about Microsoft stack versus Android stack versus iOS stack. Being able to have an environment that could handle all those things, that's what modern private CAs can do. Let's talk about VPN now for a moment. It's the same thing. It was the same thing.
Yeah.
There used to be enterprises, of course, that only gave VPN access to some of their developers and maybe some road warrior salespeople, and all of a sudden you had to have 90 to 100% of your workforce on some sort of VPN. The scalability and the automated nature of what you needed only came from a modern private CA, and that's just at the implementation stage. You also want to then automate the life cycle through of those certificates through a modern private CA as well. And an IoT, I think this is where the biggest promise lies, Tim. We've all read the headlines about IoT hacks,
Right.
and if you use a strong authenticator, such as a digital certificate, you're going to solve the majority of the problems that you're reading about in technical journalism of hacks of IoT right now. However, the cost is you're going to need to provision those devices, and then you need to manage the life cycles of the certificates on those devices. Thankfully, modern private certificate authorities can handle that.
Cool. Okay. Legacy versus cloud. A lot of these things we've hit, but I don't think all of them, Jay.
Yeah.
So.
Yeah, I think one thing that's important here
Mhm.
is, we could have probably put the term zero trust on this. And
Sure.
that's maybe the point I want to make. You see some things here about legacy systems that really work on only very specific network boundaries, if at all. And I like this word perimeterless, because once you have strong door locks, Tim, it changes the game about your ability to rigorously control access. And not only are you rigorously controlling access, but you know who and what are making authentication demands across your enterprise. And that could be from a hybrid cloud, that could be from some other API, a partner API, you name it. The whole concept of zero trust is built up by using identity-based security, and private CAs enable you to do that. So if you couple that concept, in other words, all of your hopes and aspirations about setting up zero trust, and then you combine that with something that's at the bottom of the list, which is governance, which
governance. Yep. I was going to mention that. Yeah.
Truly at the top of the list now, especially with Cybersecurity Framework 2.0, that puts governance literally at the top of the list. You combine the way to actually operationalize perimeterless authentication across your enterprise and be able to have full visibility. This is what we were talking about earlier. The ability to have visibility to the certificate life cycles, make sure that the certificates are actually configured correctly, and build a governance program that mitigates risk around using this strong form of authentication. Tim, I think that this is some of the big promises around modern cloud-based PKI versus what you had in the past. and what you're now able to employ for less than 7 figures. And it's a very proud thing that we can say now in the industry.
Yeah, for sure. So talk about this slide, Jay.
Sure, Tim. So, for so many years, you had monolithic PKI software that typically was running in a server rack. And we now see a lot of vendors of those kinds of systems saying, hey, we're now a cloud-based PKI. Tim, what that really means is monolithic software installed on somebody else's server.
On somebody else's premises being served to you, yes. As opposed to something that's designed to be a cloud application from the beginning.
So if we get down to brass tacks, Tim, if you set up, I'll give you an example, an Amazon EC2 instance with some form of legacy PKI that's installed on it, you now have the fragility associated with maintaining the configuration of that cloud instance. You also have to deal with the networking security issues around making sure that that is secure. Very easy to make mistakes. And then you haven't even begun to actually configure your what was traditionally an on-premise PKI. If you're dealing with cloud native PKI, you get rid of that entire layer of risk of your cloud fragility. Now, I love the cloud too, but a cloud instance of monolithic software is completely different than something that's been built with microservices architecture native to the cloud, which means that entire set of security and configuration risk is gone. And so if I were to use really simple terms, Tim, cloud native PKI allows you to concentrate on your use case. All those use cases we were talking about at the beginning, Tim, that's why I put all, we had at least 2 or 3 slides just on use cases. You can concentrate on your business outcomes, and you no longer have to concentrate on running a complicated PKI. You basically now can concentrate on getting your certificate profile correct, and scalability is just comes with the territory of doing cloud native PKI. It finally brings PKI into the modern age.
Got it. All right. So I guess this is what you're going to have to, these are the kinds of things you're going to have to think about.
Yeah, here's one thing. I'll give you an example. There's a bullet point here, augment or replace. And the bullet point being address the Microsoft Active Directory Certificate Services limitations. So you might be living in a world where you've had a Microsoft Active Directory Certificate Services running for 10 to 15 years, and it's done a very good job at hooking into Active Directory and putting certificates where they need to based on your group policies, etc. Problem, Tim, is we now live in a world with Linux servers, Android mobile devices, iPhone devices, IoT devices with all sorts of diversity in the operating systems. If you're not domain attached, you're not getting the certificate into that environment, period. But you might be saying, well, I can't get rid of this Microsoft Active Directory Certificate Services because it's been around so long and it runs some very key things in my enterprise. The beauty, Tim, of modern cloud native certificate authorities for private trust is that you don't have to choose to just rip and replace your MSCA. You can actually augment it. And part of what I mean by that is actually having visibility into the certificates of your MSCA through the modern certificate lifecycle management associated with the private CA. And that's just, I mean, I could go on and on about what's going on in this slide, but that's just one example of being able to, the decision making that I know all of you thinking about the current private CAs that you have in your enterprise and how you can actually then bring them together into a governance program and also augment their functionality. It's an exciting time to be in PKI.
An exciting time to be in PKI. Flexibility, resilience, adaptability, efficiency.
So Tim, think about how you are now building out digital trust in your enterprise as a total. You probably have one cloud or multiple clouds. You probably still have rack-based systems. You probably have mobile devices floating around within an office, and you probably have remote employees. Wow, you need to be able to adapt. And the efficiency of standing up those systems, the efficiency of being able to provision all of those workloads and humans and devices and have a lot of trust around the resilience of that system, making sure that your dedicated private CA that is cloud native is going to be available at every moment that you're needing it, which is basically 24/7. So, Tim, I say these are things that nobody ever took for granted, and we should never take these things for granted. But I tell you, the improvements in the technology have been leaps and bounds, and I think we needed to call out flexibility as a whole is now a new thing, it's truly part of modern private CAs right now.
Yeah, and you hit a couple of the reasons why, right over here on the left, multi-cloud environments. Like one of the facts of of our modern architecture world in which public cloud or hybrid cloud plays a significant part in so many of our work streams is that people do want flexibility, right? I want to be able to repatriate this. I want to be able to bring it in, move it out, move between public cloud providers. Like that becomes a requirement, right? And
Yes,
if you have a PKI that can't tolerate that requirement, then it's really hurting your overall performance, right? Or this next one,
exactly.
M&A, right? You never know when all of a sudden a whole new architecture and a whole new set of systems and processes are just going to crash into you like a truck. And when that happens, that's where that flexibility really comes in. You need to be able to deal with this and still have these core identity things like your PKI systems working correctly.
So if you were to really find the pattern here of what we're talking about, it is how do you extend trust where trust did not previously exist?
Mm,
And
yeah,
that's true for the multi-cloud environments. That's true for extending trust between your rack space all the way up into multi-cloud and extending trust to partners. Or my goodness, now I am owned by a different owner and we need to extend trust across ourselves, not just as a partnership, but in a very intimate way. How do you extend trust where trust did not exist before? Private CAs are the miracle of how to do that.
so let's talk about some best practices.
Tim, this is really a lot of this is up your alley because gets into compliance and governance programs within an organization. And I would say anything in security. We could actually generalize this slide for just about anything in trust and security, Tim, which is you've got to do an inventory of where your risks are. Where are your crown jewels?
Yeah,
What cannot be compromised, Tim? If you don't have an inventory of that, well, you're not doing security well. And I would say to everybody, that's your homework. If you can't tell me what your crown jewels are, there's your homework. Number two, right? I would say that once you understand those crown jewels, you have to understand where can encryption, authentication, and signing mitigate risk against those crown jewels. That's really what we're talking about in bullet point 2. And then you really, across your organization, start to do things like, we've heard the term, Tim, cryptographic center of excellence. And I'm going to start repeating that term a little more often. And that is, in more simple terms, it's having an inventory of where you already have private CAs and publicly trusted certificates. Where are your cryptographic based assets inside of your enterprise? And that is going to be both public and private together.
Right. And there's a point here that I like, which is determine the right mix of public and private PKI, because you can impair your ability to have, you know, all the capabilities and flexibility and uptime and stuff that you want if you make that decision incorrectly. Like that is a very important decision. And if you don't need to use public certs, I think we need to ask the question, why are you using public certs? Because public certs are very restrictive, and they need to be restrictive by the nature of what they are. But if you have a private PKI and you're using it entirely inside your internal network, you're the decision maker. You're the person who makes risk reward trade-offs. You're the person who decides the relative importance of these things. And you know, you can for instance have longer lived certs that wouldn't be possible in the public world, just as an example. And so making sure that you're only using public certs if you need to is a very invaluable and important decision. And also the opposite, right? If you want to have the interoperability that comes with public certificates and you try to work with a private PKI, God forbid you find yourself incapable of connecting to the systems that you want to connect to because you don't control their root stores, right? So that is like, in my mind, and tell me if you don't agree, but I think that is the very first decision you have to make.
It's huge. And Tim, I think you've made a great point, because I still hear customers who tell me they're using publicly trusted certificates for use cases.
And you go, why? Yeah, why?
And the answer, I was like, you realize that the restrictions on those public certificates are not helping you. And quite often, Tim, the answer is, yeah, but a private CA was, you know, I just think of that as being risky and complex. And
Yeah.
this is why we're having this podcast
It's difficult.
today.
I don't think why. I don't think I can do it right.
Exactly, Tim.
But that's important, Jay, because you don't want to do it wrong.
Yeah.
Right? I mean, if someone says I don't think I can do it right, my advice to them is you need a partner who can help you make sure you can do it right.
That's
Because
exactly right.
not go to public certs. Because if you go to public certs, it's basically what you're doing, right? You're saying, I'm going to partner with someone who does it right. This is going to be a global public CA who does these things by the millions, and so I have confidence that they know how to do it. Right?
Yep.
That's essentially what you're doing. Well, how about still go private PKI, which gives you these decision points that you get to make rather than them being made for you. And again, the maximum term is such a great example, but also there are plenty of opportunities to partner with a PKI expert when you do this so that you don't run afoul of that exact concern you have, which is real and important because this isn't something you want to screw up.
Tim, that's so right. Here's something else you don't want to screw up. If you're going with private CAs and private PKI, there's actually a sub bullet point here: signature either by root or intermediate. And let me tell you what that means, Tim.
Mm-hmm.
When you're going with a modern private CA, even if it's cloud native, you don't have to make a decision, a hard decision to give up your root.
Right.
If you want to have an on-premise offline root that you can hold and hug at night, that's fine, because you can use that root to sign an intermediate CA, or what we would call an issuing CA, that is hosted for you. And what I mean hosted, I mean natively cloud-based private CAs that are issuing CAs. Let me give you a real-world example, Tim. You might have a Microsoft Active Directory Certificate Services private CA running on-prem. That can issue a certificate that can sign an issuing CA in the cloud. And that can become your workhorse of issuance. And you then inherit all of these great provisioning technologies that MSCA simply does not have. And I think a lot of potential customers of these technologies think they've got to give up the root. And the answer is not at all. You can augment existing roots, or you can build a brand new root that you hold very close to your chest and use the advantages of a cloud native PKI in order to be able to extend trust across environments that your on-premise system just simply cannot.
Mm-hmm.
And so, Tim, you know, quickly going through the rest of these, I think that it's basically, you know, I definitely would never ever recommend anybody to go off and take a look at just a simple open source CA and start building things themselves, rolling your own crypto and these kinds of things, Tim, forget it. I don't know of any organization that has the full chops to do that properly. And even the biggest organizations that have all sorts of skills will come to the true experts in PKI and ask them to stand it up. So it's not really a choice. We put this on here just because for those of you who were, again, it comes down to, I'd rather do it myself because the old days were so risky or so expensive. Those days have changed. Just don't do it. And final point here, and we've mentioned this a number of times, the biggest upside to modern private CAs is the plethora of provisioning technologies that you will inherit from them that will make your life so much easier in how to get the certificates from where they need to go to where they need to go.
All right, so we are ready for questions. Before we do that, real quick, let me just say there are other ways to get involved. If you like this conversation, Jason and I, we referenced this a couple times. We have a podcast called Root Causes, PKI Security Podcast. You can find it everywhere you listen to podcasts. We have we won a Webby Award for it last year, and we'd love to have you come listen to us. And of course, you know, there's Sectigo LinkedIn and things along those lines. You can feel free to contact us to talk about Sectigo Certificate Manager. But with that, let's go to Q&A.
Brilliant. And yeah, we had a very good matching question for that last slide. Someone's asking, what updates and information sources are there to give an end user confidence and safeguards if they are not that familiar with the tech industry?
Tim, do you have a thought there?
So say the question one more time.
Where can an end user go to get information?
Oh, gee. I mean, well, there's some of the things we just said, right? There's lots of assets on the Sectigo. Like first thing, just there's a lot of assets on the Sectigo site. So you can do a bunch of things there. You can do a TCO calculator. You can do a deep dive into the technology around all of these. You know, all these things we talked about today. You can learn much more about private CA. So if you want to do some reading, you could do that. Again, we have almost 400 episodes on the Root Causes podcast. We cover a broad set of topics, and it's a great way to dive in there. They should be clearly titled so you can see what they are. We do plenty of episodes that are defining in terms. So if people are throwing around something and you say, what the heck do these guys mean by such and such? Go see if we have a topic for you. We very well may. Those are a couple things that occur to me as obvious places to start.
Sounds great. Then another question that's come in is, do you think IoT device certificates should be revocable, bearing in mind it becomes dead if you revoke it?
Yeah, I mean, yes, right? Like what if that device is just fundamentally dangerous? It's kind of a simple decision, which is if I would rather this device were a brick than a device, then revoking the cert, one hopes, would accomplish that. Right? Now, IoT gets into a complicated world, and I'll invite you to chime in here, Jason, which is those devices that are out there are not necessarily updatable. But if that device is trying to phone home and you revoke it and the phone home will no longer take the call, that may accomplish the same goal, depending on how that device works and what that device does.
So I would say, Tim, here's a real good real world example of a very long-lived certificate. In fact, certificates that are meant to live the life of a device, and that's in fact power meters that sit on the side of homes. Because those devices never connect to any network after the creation of the device. But that's one example. There are others of extremely long-lived certificates. So should those be revocable? Well, they cannot be revocable just by definition of the use case. However, I do know that there are airplanes that are taking off and landing right now
Mhm.
And Tim, the lifespan of that certificate is
Just
literally
one flight,
the length of, it's one flight. They get
right?
the renewal of the certificate happens after the flight.
Yeah. So I mean, and then the other thing is there may be devices that you'd like to be revocable, but due to connectivity and ultimately how you've made this IoT ecosystem happen, they can't be, right?
Yeah.
And that's something for people to think about when you're designing your system. Think about the whole life cycle of it. Think about these questions. Say, am I happy with these decisions I made? If one of the consequences of it is that once these devices are released into the wild, there just ain't nothing I can do. And if you say, okay, that's fine, then that's fine. But if you say, whoa, no, that's very much not fine, I need to be able to kill a device if I choose to, then you need an architecture that enables that. And that's something to think about before they're released, before they're in production, before they're being built at the design stage. Next
Okay,
question.
great. Next question. How do you protect the root CA key and the app private key?
Tim, I like to tell this story.
Please.
So when you're setting up a private CA, and of course we've got a lot of experience with this at Sectigo, being a publicly trusted certificate authority, because how in the world do you protect ultimately the keys that are involved with the issuing CAs, where you get the certificates from? And a lot of that has to do with you set up your root CA and you literally take it offline. So offline root CAs are a popular way to be able to protect that. Now, ultimately, the key generation, the private and public key generation that originated from that, if you're running a program that's important, like a publicly trusted CA, or if you're running an important private CA for your enterprise on-prem, you're typically going to want to invest in an HSM. And that HSM will generate the key pair in an extremely secure type of environment, being that HSM itself. So this is an important point for those of you who are considering cloud native PKI. Instead of having to invest in an HSM that will cost you tens of thousands of dollars just in the hardware itself, never mind the staff to be able to run it, you inherit that from the vendor who is selling you that cloud native PKI. So there's a big thing to think about there, is if you're getting that industry best practices level protection of your key generation by default. So if you're going to go off and build your own private CA, cobble it together with some sort of technology, you had better be setting it up properly and thinking about the full implications of cost of that. Because the question that was just asked, that's an important one. Making sure that from key generation of your root, how are you protecting that? And then how are you protecting every other issuing CA private key? These are important considerations that should be architected correctly. Don't leave it to the amateurs. Don't leave it to your DevOps staff. Make sure you're partnering with a good security partner that's been doing this for decades.
Great. Next question is, what has changed in the architecture of delivering PKI that has allowed these innovations, especially in onboarding?
Sorry, my audio went out there. Tim, can you help with that?
Jason, Leah, can you repeat the question one more time?
Yes, of course. What has changed in the architecture of delivering PKI that has allowed these innovations, I guess the ones we talked about in the presentation, especially in onboarding?
Yeah, I mean, I think it's a lot of the stuff that we've talked about. It's, first of all, it's just a big one is just the availability of high quality managed services from high quality vendors that are flexible to the point where you can use it for all the things you might want to do with it. Like if you think about it in the past, you really had to kind of build your own. A PKI was a computer science project, and there were some fundamental development tools and building blocks that you would use, and it was a lot like writing a software application. You were writing a software application for internal use, and that came with all of the troubles that come with that, like bugs and good design or bad design, and needing to have in-house resources that were capable of doing this, and etc. And we've seen, just the tooling that's available is so much different now than what we had, like Jason said, 15 years ago, to the point where I can sign up if I'm willing to do it. If I'm in any of the major 3 public cloud platforms, they've got the tooling, right? Now at that point, I'm locked into that platform with that PKI implementation. If I want to repatriate, I have to figure out a way to switch, but that's just an option that's available, right? Or you can get a cloud native third-party service that can move with you from location to location, from environment to environment. You've got tools that will help you with things like governance, right? I can actually go in and I can create rules, and I've got a process whereby I know what those rules are and how those have to translate into PKI implementations, and I can ensure that really happens. You have visibility, right? We talked about how you can go and you can get a report, and you understand things like, here's all the certs and here's the ones that are active, and here's their key sizes, right? And here's the encryption algorithms they're using. And that's a thing you can get. You could output that report, and then that can go into an audit. So part of it is that you got much greater capabilities, and kind of running in tandem side by side with that is much greater expectations, right? So again, if you go back in time, the idea that somebody that I, as a technology vendor, am selling my products to might actually ask me questions about things like how I encrypt data in motion and at rest would have been an absurd question. Nobody's going to ask that not in 2010, but not in 2019, they wouldn't have asked that. But now in 2024, they all ask that. And so suddenly this becomes another area where the stakes have gone up, where if I want to meet the requirements that are being asked of a modern day production system and a modern day architecture, I need to be able to do things that I never needed to be able to do for. And it is things like flexibility of environment. It is things like extreme invisibility. It is things like a great deal of control that perhaps in the past were just not visible. People weren't understanding the consequences. People weren't understanding why it mattered and why it was important. I'm not sure if that exactly answers the question. Do you want to add to that, Jay? Are we good? Okay, I think we're good. Yeah.
Okay, great. Then the next question was, how can my organization better take inventory of cryptographic assets and also become aware the areas where a private PKI can help?
I have 2 approaches to think about in starting. Number one, think about it on a use case by use case basis. In other words, if you think about it just by certificates, it might be unintuitive to your teams. Your teams in IT are really responsible for uptime of specific use cases. So you're thinking about if there's knowledge that you have certificates going into mobile devices for the purposes of Wi-Fi access point authentication, write that down, right? There's a use case. We're guaranteed there's certificates behind the scenes. If you have a website, guaranteed you are running publicly trusted certificates of some kind. Write that down. That's another one. But then I would say the next category of how to do your inventory is to actually use certificate lifecycle management to perform discovery. And that is one of the pillars of certificate lifecycle management, where the discovery of both private and public certificates is part of that tool. And you don't run it just once, you run it on an ongoing basis to make sure you're capturing everything. And that's another great way of taking your cryptographic asset inventory.
Right. And next question is, how is quantum cryptography going to change this?
Yeah, we almost made it through a whole podcast without talking about post-quantum cryptography. Shame on us. Jay, post-quantum cryptography.
Tim, yeah, it is a gigantic topic. And what I would say is this. Here is two things I want to leave everybody with. First answer is, it's going to change everything. There's the blanket answer. But I think more importantly for everybody here from a practical level, remember we were talking about crown jewels on this webinar today. When you are considering your crown jewels, you should categorize them. If you have digital crown jewels where you need those secrets to be still secrets in 10 years, 15 years, 20 years from now, and we're talking about everything from mortgage contracts to intellectual property for inventions that you have, to you name it. If you have digitally signed a document, or if you have encrypted data that you want to maintain as a secret past the quantum apocalypse, you need to start looking at really what it takes to implement a private CA that is post-quantum computing resistant, right? So in other words, it can exist beyond the quantum apocalypse. And Tim, I know you have a lot more to say about that, but that's really it in a nutshell. It's a great question. We didn't bring it up in this webinar, but it is something people should be thinking about in conjunction while you're thinking about your crown jewels.
Yeah, and I think I would add that certainly there are real world applications where people are using post-quantum cryptography today. So it's not that it's not possible. I do think that is very advanced. And for most of us, unless we are a born in the cloud technology provider with major resources available, I think we probably want to be thinking about that as an important future that we're going to embrace when our vendors are there to support us with software and hardware and services that are suitable to PQC, post-quantum cryptography. I don't think most of us are going to go try to roll our own, because that's back to the world of a very real science project. And if you want things to be plug and play and have that reliability and that that interoperability and those other things that come with the plug and play, tried and tested, fully QA'd, vendor provided resources, today in 2024, that's not what you're getting in the world of PQC. You're really getting into the wild and woolly world of software development. And the primitives exist and all that stuff exists, but just understand what you're taking on. And I think that very large, very well-resourced organizations with high value targets are looking to implement and do this now. But we're talking like global financial institutions or tech giants. And if you're one of those, yes. If you're not one of those, probably not yet.
Great. I think we've probably got time for one more question. Is there any reason why you should or shouldn't use public CA-issued SSL certificates for instances within an enterprise for internal communications?
Yeah, like you can, right? You probably can, but it may make things harder on you. And again, go back to the perfect example is root maximum term, right? You have maximum term on public certs, and the maximum term on a TLS certificate today is 398 days, and we have clear communication from major browser root programs that in the foreseeable future, we don't have a specific timeline, but that in the foreseeable future, that's going to be dropped to 90 days. So if you don't want to be swapping out your certs, and we're not going to let those go to the last day, so in reality, what would you be swapping them out every 60 days? So if you don't want to be swapping out your certs every 60 days, you may not have a choice if you're using a public CA, but if you're using a private CA, it's your PKI, you get to make up the rules, you get to evaluate risk versus reward, and you have flexibility to make different decisions, right?
Tim, I'd like to add a piece to
Sure.
that around, remember, for those of you who are privacy conscious and you don't want to give away all the information about how your internal systems are architected, remember that every publicly trusted certificate is publicly noted in the CT logs, which means you might be referencing servers and names of servers that are internal, and for that reason alone, I just cannot recommend using public trust certificates internally unless you have a really good reason.
You might be giving somebody the map to your network. That's right. Absolutely true, Jason. And then the other thing to be aware of is revocations. Sometimes a CA must revoke your certs, and it has no choice, and it has to do that because that's the rules it must follow and what it signed up for when it decided to become a public CA. And this can happen to any public CA, and it can happen under any set of circumstances. And again, you don't get to evaluate risk. You don't need to get to look and say, I know these certificates are misconfigured, but they're misconfigured in a way that's irrelevant to me, so I'm just going to let them run out their lifespan. You don't get that choice if you're on a public PKI, right? If you are using your own PKI, you do. So I think you're absolutely right, Jay. I think this confidentiality and privacy concern is very real, and I think the flexibility and control concern is very real. And those are two very powerful arguments to go with private CA. Though once again, you have to be really confident that you're going to ensure interoperability. And if you can't have 100% control of every machine that has to connect to the servers where these certs are implemented, then you need public.
Great. Okay, I think we answered the majority of questions, and as we're coming up for the hour, thank you everyone for your time. Thanks, Jason and Tim.
Thank you.
If you've got any more questions, do get in touch with Sigtigo directly. If you like this webinar, keep an eye on our website where we announce upcoming webinars. And for now, thank you and have a good rest of your day.
Come listen to the podcast.
Got it. Take care, guys.
Thank you.